In this video, you'll learn how to wire a two-wire DC sensor, like a switch or a contact, to a PLC input card. You'll also learn what a two-wire discrete sensor is and recognize some of the common types of two-wire discrete sensors, or a process to the PLC program. Knowing these input states can allow the PLC program to make decisions, such as when to start or stop a pump. In this diagram, the Programmable Logic Controller, or PLC, is running a ladder logic program. The push button is connected to a PLC input card, and the logic program is written to sense the state of the push button. When the push button is not pressed, the logic does not turn the pump on. Now, if the push button is depressed, the PLC ladder logic program will sense that the push button has been pressed and will start the pump. So, let's see how we can make this important input information available to a PLC program. In order to do this, we need to understand more about these discrete sensors and how they're wired to the PLC. Discrete DC sensors, or discrete direct current sensors, operate in a circuit with a battery or other power source, commonly known as a power supply. A power supply is placed in an electrical circuit to provide power to the connected devices, like a switch or a lamp. DC power supplies are referred to by their voltage and capacity, indicated by how many amperes they can supply. The more amperes a power supply can deliver, the larger and more expensive they generally are. In DC PLC circuits, the power supply almost always supplies 24 volts DC to the connected devices. In this diagram, a DC circuit is shown, which turns on a lamp when a push button is pressed. The common trait of all discrete DC sensors is that they have exactly two operating states, on and off. A discrete DC push button, as in this diagram, is on when it is pressed and its internal contact is closed, forming a complete circuit and allowing the flow of electrons. When the push button is released, its contacts are opened again. The circuit is broken, and the flow of electrons stops. The state of the push button is off. Other common examples of discrete DC sensors include proximity switches, selector switches, and photoelectric sensors. If we want to monitor the state of the push button in the PLC, we would need to connect the two wires of the push button to a digital input card in the PLC. When the push button is not pressed, the PLC would see the input state as off, or as a 0. The circuit to or from the PLC input is open or not energized. When the button is pressed, the PLC input senses the change in push button state and transmits this data through a communication channel to the processor memory, or data table. When the push button is pressed, the circuit to and from the PLC input is closed, or energized. We could then write a PLC program, which resides in the memory of the PLC, to take some action, like turning on a lamp or a pump when the push button is pressed. Wiring a discrete DC sensor to a PLC input card is easy and straightforward. In this video, we will consider only devices that have two wires that need to be connected to the PLC digital input card. An example, a Hall effect proximity switch, is shown here. In a separate video, we will consider more complex three-wire devices. For most PLCs, the input cards must match the type of circuit that will be employed to interface the device to the PLC. For example, a discrete DC device must be wired to a discrete DC input card. A discrete AC device would require a discrete AC input card. In this video, we will only consider DC devices. In order to connect a two-wire discrete DC device to the PLC, we will need to identify whether the device is polarized or non-polarized. For a polarized device, the two wires will be labeled. One wire is labeled positive and one wire is labeled negative. In this simplified diagram of a photoelectric switch, the positive wire must be connected to the positive terminal of the PLC input, and the negative wire must be connected to the negative terminal of the PLC input. If this convention is not followed, the device will not indicate correctly in the PLC, and the device may be damaged. For this photoelectric switch, reversing the positive and negative wires will damage the phototransistor, and there will be no power to the transmitter. The switch will not function as intended. For non-polarized devices, like simple push buttons and selector switches, the device may be wired with either wire connected to the positive terminal of the PLC card and the other wire connected to the negative terminal of the PLC card. In this example, the proximity switch is a non-polarized device. It has two wires, a white wire and a black wire. On the left, the white wire is connected to the positive terminal of the digital input channel, and the black wire is connected to the negative terminal. Because the device is non-polarized, the wires could be connected in the opposite configuration and still provide the correct indication of its state in the PLC. This is depicted in the drawing on the right. Now, let's see how two-wire discrete DC sensors are connected to actual PLC I/O cards. This is a schematic of a Siemens SM321 digital input card, part number 6ES7-321-7BH01-OABO. It is a 16-channel, 24-volt DC digital input card that is very popular in Siemens PCS7 and S7300 PLC systems. This digital input card wiring scheme is similar to most digital input cards used in the process industries. The SM321 has 20 screw terminals to which the digital inputs are connected. As we saw previously, for two-wire discrete DC sensors, each digital input requires the connection of two wires. The SM321 card requires 24-volt DC power to perform several functions. First, the card itself requires power to light the status LEDs, perform diagnostics, and to communicate the card's input statuses back to the PLC. Power to the card is supplied by a 24-volt DC power supply connected to terminals 1 and 20. Internally, inside the SM321 card, this same 24-volt DC power is connected to terminals 10 and 11. The power at terminal 10 supplies power for the top group of 8 digital inputs, and the power at terminal 11 supplies power for the bottom group of 8 digital inputs. Let's just focus on the top 8 inputs, labeled as input 0 through input 7. In practice, the PLC input card channel connections, terminals 2 through 9 and 12 through 19, will be brought out to a terminal block. These marshalling connections, as they're called, allow the field wires to be more easily terminated in the control panel. These terminals are represented by the letters A through H in this diagram. The installer usually pre-wires the marshalling terminals, Terminal 2 on the SM321 card to Terminal A, Terminal 3 to Terminal B, and so on. Now, let's connect the proximity switch and the photoelectric switch from the previous examples to the SM321 card. The 8 marshalling terminals, A through H, are wired to channels 0 through 7, and are the negative terminals in our discrete circuits. Plus 24-volt DC will be obtained from Terminal 10 for the top 8 inputs, wired to the SM321 card, and from Terminal 11 for the bottom 8 inputs, wired to the SM321 card. Since the push button is a non-polarized 2-wire discrete device, we can connect either its white or black wire to 24 volts DC, and the opposite wire to Terminal A. For a polarized device, like the photoelectric sensor, care must be taken to connect the positive wire, or the red wire, to the 24-volt DC, and the black wire to the negative terminal, or the PLC input card connection. If we connect the photoelectric switch to PLC input channel 3, the red wire will be connected to 24-volt DC, and the black wire will be connected to Terminal D. To review, we have learned that there are many types of discrete 2-wire DC sensors that can be wired to a PLC input. Some devices are polarized, and some are non-polarized. For polarized devices, it is important to connect the positive wire to the power, or positive terminal, of the PLC input, and to connect the negative wire, or common, to the negative terminal of the PLC input. For non-polarized devices, either wire can be connected to the positive terminal, with the opposite wire connected to the negative terminal. A schematic of your specific DC digital PLC input card is required to determine how your specific device should be wired. The terminals connected to 24 volts DC are the positive terminals. In this example, the PLC input card terminals are the negative terminals.